D-E-P-E-N-D-E-N-T. Do you know what that means? I-N-D-E-P-E-N-D-E-N-T. Do you know what that means? She got her own house. She got her own car. 2 jobs, work hard. You a bad broad. If you ain't all... Hello and welcome back to our next section of math. Today we are on 3.4 and we are going to be writing and analyzing biconditional statements and determining if a definition is good. So some vocabulary today. A biconditional statement it's two ways. So remember, bi means two and conditional statements are if-then statements. So they are statements that can go in both directions. So the hypothesis to conclusion is true, and the conclusion to the hypothesis is true. A statement that can be, so it's a statement that is written in the form of hypothesis, if and only if conclusion. P, if and only if Q. And the shorthand for if and only if is IFF. So I double F. So this means if P, then Q, and if Q, then P. A definition is a statement that can be written as a true biconditional. So it's when the biconditional is true. If we were to create a Venn diagram of a biconditional statement, then it would be two things that perfectly overlap each other. P and Q, the hypothesis and the conclusion, would perfectly overlap each other. So by the end of this video, hopefully you'll be able to determine if the definition of independent was a great definition or not so good. So biconditionals use the term if and only if. For a biconditional to be true, both the conditional and the converse need to be true. If hypothesis, then conclusion, and if conclusion, then hypothesis, both need to be true in order for the biconditional to be true. In geometry, a definition is a good definition when the biconditional is true. So here we have two, I lost my pen. There we go. We have two shapes. The triangles is going to have a good definition, and quadrilaterals is going to have not such a good one. So the reason why triangles is a good definition is that it's specific and they mean both a triangle and a three-sided polygon are literally the same thing. And so the way that we can write the biconditional statement is a shape is a triangle if and only if it is a three-sided polygon. So it's hypothesis, if and only if conclusion. Hypothesis, if and only if conclusion. Whereas this quadrilateral, we can still write a biconditional statement. A shape is a quadrilateral if and only if it has four sides. And you might be saying, well, it works both ways. If a shape is a quadrilateral, it has four sides. If it has four sides, a shape is a quadrilateral. But it's not quite specific because a triangular pyramid has four sides. The three sides here and then one on the base. And so that could be a counterexample to this not as specific definition. So since the converse of this biconditional, if a shape has four sides, then it is a biconditional, it's not true. This is not a good definition. However, if we say a quadrilateral is a four-sided polygon, that's a better definition. A figure is a quadrilateral if and only if it is a four-sided polygon. So remember, biconditionals, for a biconditional to be true, you need to be able to write the conditional statement. If a figure is a quadrilateral, then it has four sides. And the converse. If a figure is a four-sided polygon, then it is a quadrilateral. Having both the conditional and the converse be true, we know that the biconditional is also true. Also remember that the conditional and the contrapositive are always mutually exclusive. So if the conditional is true, the contrapositive is true. If the converse is true, the inverse is true. And since both of these are true, it makes all four of the related conditionals true. So in this case, the conditional, the converse, the inverse, and the contrapositive are all true. Therefore, the biconditional is true. And since the biconditional is true, this is a good definition of what a quadrilateral is. A quadrilateral is a four-sided polygon. So now let's take a look at this. Determine if the following is a good definition. Tam High is a high school. So first, let's make it into a conditional statement. A conditional statement could be, if a school is called Tam High, then it is a high school. The converse would be flipping it. So if a school is a high school, then it is called Tam High. Now, if a school is called Tam High, then it is a high school. That's a true statement. I haven't heard of anything called Tam High that is not a high school. But if a school is a high school, then it is called Tam High. So to prove that this is false, we need to figure out a school that is a high school, but makes the conclusion false. That is not called Tam High. So this is false because Redwood is an example. Redwood is a high school, but it is not called Tam High. So a biconditional statement is a school is called Tam High if and only if it is a high school. This would be considered false because the converse is false. A school is called Tam High if and only if, this is making it the biconditional statement, if and only if it is a high school. So since the biconditional is false, since the converse is false, the biconditional is false, and therefore the above statement is not a good definition. So how could we make Tam High have a good definition? So a good definition for Tam High is a public high school in Mill Valley. That might be a better definition because if you have a public school in Mill Valley, then it is called Tam High. That, from my understanding, Tam High is the only public high school in Mill Valley. So now, how is the independent definition of having your own house, your own car, and 2 jobs, is that a good definition? Why or why not? After that, make sure that you take the online quiz from the link following. Have a good day. Bye-bye.